There is no specific limit to the number of subpanels in a residential building according to the National Electrical Code. However, it's essential to consider the total number of branch circuits and subpanels in the overall design of the electrical system to ensure proper load distribution and safety. An electrical application with a main distribution panel feeding multiple subpanels is feasible and can be installed safely. Several points should be taken into account. Firstly, ensure that the main distribution panel is rated for the total amperage of the subpanels and any other loads connected to it. Secondly, all circuit breakers in the main distribution panel and subpanel should have the same short circuit current rating. The main disconnect should be located outside and be accessible in case of emergencies. The feeder conductors connecting the main distribution panel to the subpanels should be appropriately sized for the amperage of the subpanels they serve. The generator transfer switch should be rated for the total amperage of the vital loads and should be installed according to the manufacturer's instructions. Finally, the distribution of loads across the subpanel should be balanced to prevent any overloading. Distributing loads across multiple subpanels allows for more efficient load management and easier troubleshooting. Having separate subpanels for different floors provides more flexibility in circuit arrangements and any future expansions. Isolating the generator-powered circuits in a separate subpanel enhances safety and reliability during power outages. Installing multiple subpanels can increase the overall cost of the electrical system. Subpanels require space for installation, so it's important to plan their placement carefully to ensure accessibility. Maintaining and inspecting multiple subpanels may require additional time and effort compared to a single large panel. The electrical application described is feasible and can provide benefits for a large home with multiple floors. However, it's important to carefully consider the design, installation, and maintenance aspects to ensure a safe and efficient electrical system. When planning an electrical system with multiple subpanels, remember that the National Electrical Code doesn't impose a hard limit on the number of subpanels. What matters most is that the entire system is designed and installed to handle the expected loads safely and efficiently. Consider the panel ratings. The main distribution panel must be rated to handle the combined amperage of all the subpanels it feeds. This ensures that the main panel isn't overloaded, which could lead to overheating and potential fire hazards. Also, the subpanels themselves must be rated appropriately for the loads they will serve. Circuit breaker ratings are also important. All circuit breakers, both in the main panel and the subpanels, must have an adequate short circuit current rating. This rating indicates the maximum fault current that the breaker can safely interrupt. Using breakers with insufficient ratings can lead to breaker failure during a short circuit, which can cause significant damage and increase the risk of electrical fires. A main disconnect is essential. A main disconnect located outside the house provides a convenient and safe way to de-energize the entire electrical system in case of emergencies, such as fires or floods. It allows first responders to quickly shut off the power to prevent further hazards. Subpanel feeder sizes are also important. The conductors that feed the subpanels from the main distribution panel must be sized correctly to handle the amperage of the subpanels. Undersized conductors can overheat, leading to insulation damage and potential fires. Use appropriate wiring based on ampacity charts in the NEC, such as those found in Table 310.15b16. Generator transfer switches are critical. If the homeowner wants to connect a generator to power essential circuits during outages, a properly rated and installed transfer switch is essential. The transfer switch isolates the generator power from the utility power, preventing backfeed, which can be dangerous for utility workers and can damage equipment. Consider load distribution. Balancing the loads across the subpanels is crucial for efficient operation. An unbalanced system can lead to some subpanels being overloaded while others are underutilized. This can cause voltage drops, equipment malfunction, and increased energy consumption. Distributing loads evenly ensures that each subpanel operates within its rated capacity. There are several advantages to using multiple subpanels. Improved load management is one. With multiple subpanels, it's easier to manage and isolate different circuits. If there's a problem in one area of the house, only the corresponding subpanel needs to be shut down, minimizing disruption to other areas. Flexibility is another. Separate subpanels for different floors or sections of the house provide flexibility for future expansions or modifications. New circuits can be added without affecting the existing wiring in other areas. Enhanced safety is another advantage. Isolating critical circuits, such as those powered by a generator, in a separate subpanel enhances safety during power outages. This prevents accidental overloading and ensures that essential systems continue to function reliably. However, there are also considerations to keep in mind. Installing multiple subpanels can increase the initial cost of the electrical system due to the additional panels, breakers, and wiring required. Space is another consideration. Subpanels require space for installation, so it's important to plan their placement carefully. Ensure that the subpanels are easily accessible for maintenance and troubleshooting. Maintaining and inspecting multiple subpanels can be more time-consuming compared to a single large panel. Regular inspections are essential to identify potential problems such as loose connections or corroded wires before they escalate into more serious issues. In summary, using multiple subpanels in a large home can be a practical and efficient solution for managing electrical loads. The National Electrical Code does not restrict the number of subpanels, but it's essential to adhere to safety guidelines and best practices. Carefully consider panel ratings, circuit breaker ratings, main disconnects, subpanel feeder sizes, generator transfer switches, and load distribution to ensure a safe and reliable electrical system. Remember to consult with a qualified electrician to design and install the system according to local codes and regulations. This ensures that the electrical system meets the specific needs of the home while maintaining the highest standards of safety and performance. When planning the electrical system, start by calculating the total load for the entire house. This involves adding up the wattage of all the appliances, lighting fixtures, and other electrical devices that will be used simultaneously. Use the load calculations to determine the required amperage for the main service panel. Next, determine the appropriate size and number of subpanels based on the load distribution throughout the house. Consider the layout of the house and the location of major appliances and equipment. Place subpanels in areas where they can efficiently serve the loads in that particular zone. Ensure that each subpanel is adequately sized to handle the expected loads, with some extra capacity for future expansion. Select high-quality circuit breakers and other electrical components that meet or exceed industry standards. Use copper wiring of the appropriate gauge for all circuits. Pay close attention to grounding and bonding to ensure that the electrical system is properly grounded. Follow the National Electrical Code guidelines for grounding and bonding to minimize the risk of electrical shock. Install surge protection devices at the main service panel and subpanels to protect sensitive electronic equipment from voltage spikes. Coordinate with the local utility company to ensure that the electrical service is adequate for the planned electrical system. Obtain all necessary permits and inspections to ensure that the electrical work complies with local codes and regulations. Document the entire electrical system, including panel schedules, wiring diagrams, and equipment specifications. This documentation will be helpful for future maintenance and troubleshooting. Educate the homeowner about the operation and maintenance of the electrical system, including how to identify potential problems and what to do in case of an emergency. Encourage the homeowner to schedule regular inspections by a qualified electrician to ensure that the electrical system remains safe and reliable. By following these guidelines and best practices, it is possible to design and install an electrical system with multiple subpanels that provides safe, efficient, and reliable power to a large home. Remember that the key to a successful electrical system is careful planning, quality workmanship, and adherence to established safety standards. Understanding the principles of electrical distribution and load management can help homeowners and electricians create electrical systems that meet the needs of modern homes while ensuring the safety of the occupants. When planning an electrical system for a large home with multiple floors, consider the following specific recommendations. Install a main distribution panel in the mechanical room on the bottom floor to serve as the central hub for the electrical system. This panel should be sized to handle the total load of the entire house, with adequate capacity for future expansion. Use appropriately sized feeder conductors to connect the main distribution panel to the subpanels on each floor. The feeder conductors should be sized according to the National Electrical Code guidelines, taking into account the amperage of the subpanels and the distance from the main distribution panel. Install separate subpanels on each floor to serve the loads on that particular floor. This allows for more efficient load management and easier troubleshooting. The subpanels should be located in easily accessible areas and should be sized to handle the expected loads on each floor. Consider installing a dedicated subpanel for the mechanical equipment in the mechanical room. This subpanel can be sized to handle the loads of the furnace, air conditioner, water heater, and other mechanical equipment. This isolates the mechanical equipment from the other circuits in the house, making it easier to troubleshoot any problems. Install a generator transfer switch to allow the homeowner to connect a portable generator to power essential circuits during power outages. The transfer switch should be sized to handle the total load of the essential circuits and should be installed according to the manufacturer's instructions. Design the electrical system with future expansion in mind. Install empty conduits and junction boxes to allow for the addition of new circuits and subpanels as needed. Use a labeling system to clearly identify all circuits and subpanels. This will make it easier to troubleshoot any problems and to add new circuits in the future. Provide the homeowner with a detailed electrical system diagram and a panel schedule. This will help the homeowner understand how the electrical system is wired and how to operate it safely. By following these recommendations, it is possible to design and install an electrical system for a large home with multiple floors that meets the needs of the homeowner while ensuring the safety and reliability of the electrical system. Remember to consult with a qualified electrician to ensure that the electrical work is done correctly and in accordance with all applicable codes and regulations. It is also essential to ensure that the electrical system is properly maintained and inspected on a regular basis to prevent any potential problems. This includes checking the circuit breakers, wiring, and other electrical components to ensure that they are in good working condition. Any damaged or worn components should be replaced immediately to prevent any electrical hazards. Additionally, it is important to educate the homeowner about electrical safety and how to use the electrical system safely. This includes teaching them how to avoid overloading circuits, how to use extension cords safely, and how to respond to electrical emergencies. By taking these precautions, homeowners can help to ensure that their electrical system remains safe and reliable for years to come. In addition to the above recommendations, it is also important to consider the specific needs of the homeowner when designing an electrical system for a large home. For example, if the homeowner has a home office, it is important to provide dedicated circuits for the computer, printer, and other office equipment. If the homeowner has a home theater, it is important to provide dedicated circuits for the television, sound system, and other entertainment equipment. If the homeowner has a swimming pool or hot tub, it is important to provide dedicated circuits for the pump, heater, and other pool or hot tub equipment. By considering the specific needs of the homeowner, it is possible to design an electrical system that meets their unique requirements and enhances their lifestyle. Remember to consult with a qualified electrician to ensure that the electrical work is done correctly and in accordance with all applicable codes and regulations. It is also essential to ensure that the electrical system is properly maintained and inspected on a regular basis to prevent any potential problems. By taking these precautions, homeowners can help to ensure that their electrical system remains safe, reliable, and tailored to their specific needs for years to come. When evaluating the feasibility of installing multiple subpanels in a residential building, consider the load diversity. Load diversity refers to the fact that not all electrical loads will be operating at their maximum capacity simultaneously. For example, the air conditioner may be running at the same time as the refrigerator, but the lights may be turned off in some rooms. Taking load diversity into account can help to reduce the overall size of the electrical service and the subpanels. Consult with a qualified electrician to determine the appropriate load diversity factor for the specific building. This will help to ensure that the electrical system is sized correctly and that it can handle the expected loads without being overloaded. Another important consideration is the voltage drop. Voltage drop refers to the decrease in voltage that occurs as electricity travels through a wire. Excessive voltage drop can cause appliances and equipment to operate inefficiently or to fail altogether. To minimize voltage drop, it is important to use appropriately sized wires and to keep the wire runs as short as possible. The National Electrical Code provides guidelines for calculating voltage drop and for selecting the appropriate wire sizes. Consult with a qualified electrician to ensure that the electrical system is designed to minimize voltage drop. In addition to the above technical considerations, it is also important to consider the aesthetic aspects of the electrical system. Subpanels can be bulky and unsightly, so it is important to plan their placement carefully. Consider locating the subpanels in closets, basements, or other out-of-the-way areas. It may also be possible to conceal the subpanels behind decorative panels or doors. The goal is to minimize the visual impact of the electrical system while still providing easy access for maintenance and troubleshooting. Remember to consult with a qualified electrician to ensure that the electrical system is both safe and aesthetically pleasing. When planning the electrical system for a large home, consider the use of smart home technology. Smart home technology can automate many of the functions of the electrical system, such as lighting, heating, and cooling. This can improve energy efficiency, enhance comfort, and provide greater convenience. For example, smart lighting systems can automatically turn off lights when rooms are unoccupied, and smart thermostats can adjust the temperature based on occupancy and time of day. Smart home technology can also provide remote control of the electrical system, allowing homeowners to monitor and control their homes from anywhere in the world. There are many different types of smart home technology available, so it is important to research the options carefully and to select the products that best meet the needs of the homeowner. Consult with a qualified electrician to ensure that the smart home technology is installed correctly and that it is integrated seamlessly with the existing electrical system. Another important consideration is the availability of emergency backup power. Power outages can occur for a variety of reasons, such as storms, equipment failures, or grid disruptions. To ensure that essential systems continue to function during power outages, it is important to have a reliable source of emergency backup power. There are several different options for emergency backup power, such as generators, batteries, and uninterruptible power supplies, UPS. Generators are typically used to provide backup power for the entire home, while batteries and UPS systems are typically used to provide backup power for specific appliances or equipment. The choice of emergency backup power system will depend on the specific needs of the homeowner and the budget. Consult with a qualified electrician to determine the best emergency backup power system for the home. Remember that safety should always be the top priority when working with electricity. Always follow the National Electrical Code guidelines and consult with a qualified electrician to ensure that the electrical system is installed and maintained safely. Never attempt to work on electrical systems if you are not qualified to do so. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical shock. By following these guidelines, homeowners can help to ensure that their electrical systems are safe, reliable, and efficient for years to come. Always remember to prioritize safety and consult with qualified professionals when making decisions about electrical systems.